All right, we're back. We are on page 1, I think. Is that how I numbered these? Yeah, we are on page 1 of notes 3 of Calc C, and we're going to talk about sequences. Kind of important. So sequences they have a weird relationship to what we really want to study. And it's that we kind of like start with a sequence, we create a series, and then from the series we create a sequence, and then we look at the sequence, see what it does, tells us something about the series. You don't need to understand that right now. But that's why I'm saying that they're kind of important. And I'm not saying that they are like the single most important thing we're going to do. So like, you got to understand them, but we use them more than we rely on them, I guess. I don't really know what I'm saying here. Anyway, a sequence is just basically like the outputs of a function whose domain is the positive integers or the non-negatives usually. So the positives would be 1, 2, 3, 4. The non-negatives would be 0, 1, 2, 3, 4, and so on. So you already know a bunch of them. So for example, you got your Fibonacci sequence here. I'm not going to try to spell that. I think it's N-O-C-C-I. I don't know. You got your counting numbers, or these are your non-negative integers. So you could say that this is like Z plus. Integers is Z, and then the plus means just the positives. And then you got here 1 over 1, 1 over 2, 1 over 3. These are your reciprocals. So these are just sequences that you've probably seen before. And if you look at them, like there's the first term, the second term, the third term. So it depends on how you're counting too. So this is the first term, second term, third term. But you also might say this is the 0th term, which is weird, first, second. So it just depends on where you decide to start. And you're usually told where you're starting. So like that's another thing, don't worry about all that much. They do have their own weird notation. So it looks like this. So it's to distinguish it from just a normal function, I suppose. And what you do is you just put in braces, right? And so instead of saying like f of x, you say the braces of a sub n, and then a sub n is the function that's going to generate your sequence for you. So if we look at it, we can, let's try this problem. So we want to write out the first few terms of the sequence with a sub n is equal to n plus 1 over n. So n plus 1 over n shouldn't be that hard to work with. Well, hopefully, shouldn't be that hard to work with. So if n is 1, we would get 2 over 1. Usually you want to actually like write them out. So like 2 over 1 is 2, but it's better to write it as 2 over 1 because it kind of preserves, you know, what's happening there. And then here, 3 halves, 4 thirds, 5 fourths, 6 fifths. So a thing here, if you look at this, you know, if n approached infinity, if n were to if n were to approach infinity, what would happen to this sequence? Well, you can tell that the terms of the sequence are approaching 1. So we'd actually say that this sequence converges to 1 because it has a limit of 1. And that's one of the things that we want to work out. Let's try this one. Write out the first few terms. All right, so a sub n is annoying in this case because it has a cosine of pi n in it, but that's all right. So when n is 1, we get the cosine of pi, which is -1. So I'm going to say negative 2 to the first. When n is 2, we get the cosine of 2 pi. The cosine of 2 pi is the same as the cosine of 0, which is 1. So we get 2 squared. And then 3 is 3 pi, which is basically the same as pi. So we're back to negative 2 cubed. And then we'll be back to positive, negative. So for a variety of reasons, this one is not converging. So first of all, if you notice, every other term is positive or negative. It keeps it's like a light switch going on and off. This is called an alternating sequence. It's called that because it literally alternates positive, negative, positive, negative. An alternating sequence needs to alternate. It can't go like plus, plus, minus, minus, plus, plus, minus, minus. It has to strictly go positive, negative, or it could start negative and go negative, positive, negative, positive. It's a big deal. The other thing to know is, and it's kind of like written down here, cosine of pi n is a super weird way, in my opinion, of writing -1 to the n. So your calculator actually will do this very strange thing. And let me see if I can share that with you actually, where it will, if it doesn't know what to do. So like the calculator tries to do things. So for example, I'm gonna have the calculator, I'm gonna give it an infinite sum that it can actually find. So I'm gonna go from 0 to infinity of like 1/5 to the n. Okay, so, and it's gonna give me an answer, gives me an answer, right? When it doesn't know what to do, it just does like little mathematical things that aren't like wrong, but don't help you. So like here, if we ask it what to do, this actually doesn't have a finite sum. So it doesn't know what to do. So it's just gonna replace -1 to the n with cosine of pi times n. It's really weird. And I just wanted to like, as soon as I could get that into the notes so that you would realize it, because you're probably gonna see it if you play around on your calculator enough. Very strange. So like as humans, there's no reason we would do that. You would think that as like a calculator, there'd be no reason for it to do it, but there you go, did it anyway. So this sequence that we just worked with, we got a negative, a positive, negative, positive, negative, positive, negative. So if we were getting closer and closer to 0, then maybe we could say that the limit of this thing is 0 and that therefore the sequence converges on 0. But actually, we're just getting farther and farther away as we alternate. So it's alternating and it's kind of like diverging toward a positive infinity and a negative infinity. This one just doesn't converge at all. There's nothing for our purposes that's really great about that sequence, but it is a sequence. So a series, which is what we like really want to talk about, a series is the sum of the terms of a sequence. So what we do is we take a sequence. So for example, this first one that we looked at, right? The first term is this, the second is this, the third is this, and so on, right? So what we'll do is to create a series, we just add them up. So instead of having commas between these, which is what a sequence will have, we just add. So we'll have pluses in between them. So every sequence can be turned into a series just by adding up the terms. And we're going to want to answer the question of, if we add up the terms and we go to infinity, do we get a finite value, or does it just spin out of control to infinity or negative infinity, or does it just keep bouncing back and forth between like 5 and 10, 5 and 10? Like, we want to know what's going to happen. So let's see if we can write out what are called the partial sums. So partial sums, a sum, a full-on sum, would be the full thing, right? Go from 0, start with 0, and then end at infinity, whatever it means to end at infinity. A partial sum will first go from 0 to 0. And so that's literally just the first term, which is 1 in this case. So actually, because 2/3, so if I wrote out some of the terms of this, it would be plug in n equals 0 here, right? And you get 2/3 to the 0, which is 1. Then you do plus, plug in 1, that'll be 2/3. Plus, plug in 2, that'll be 2/3 squared, plus 2/3 cubed, plus dot, dot, dot. So what I'm gonna do is I'm gonna let the calculator do this work because there's no chance I'm doing this by hand. So we have to find the 0th partial sum up to the 6th partial sum, then see if it has a limit. So let's see what we can do. So there's actually a couple things we can try to get the calculator to do here. So the first thing I'm gonna do is I'm going to say that n goes from 0 to k. And the reason I'm using k there instead of infinity is I want to be able to vary that so that I'm only adding up k terms, right? So okay, well, spoiler, I accidentally hit enter. I need to give k a specific value. So I'm gonna say k is equal to 0, right? So what this does is it takes the first term of the series, which is 2/3, nope, which is 1, and it adds it to nothing. So the first partial sum when n equals 0 is just 1. Now I'm going to change it so that k equals 1, and I can press enter, or I could do like, I'm going to do that, and do 1.667. So it got bigger, right? So at this point, maybe it's going to just spiral out of control to infinity. Maybe it's going to converge on, I don't know, like it could converge on 5/3. Let's see, plug in 2, I'm going to do control enter, 2.11. So it got bigger. So 2.111, and then let's go 3. So I'm writing these in on the notes, 2.4. So it's getting bigger, maybe it's converging on like 2.5 maybe. Just trying to speculate. 4, 2.6. Okay, so it's still growing, but it's growing less. 2.605. And then 5, 2.7. I don't know if the table is like big enough for us to actually like infer what the limit is going to be. 6, 2.82 is still just growing. 2.824. Okay, so now, remember when I just pressed enter accidentally instead of giving it a specific value? So I just pressed enter and the calculator did some math. And what math did it do? We'll talk about that later. But it did some math and it got this, right? So this is what happens when k is a specific value. So instead of doing what I did, I could have just done this such that k equals, let's say 0, right? We get 1, which we put in our table. K equals 1. 5/3 or this, 2. So this is spitting out the values. This is a formula for the kth partial sum. So if k is going to be 50, that means we're summing up from 0 to 50. It'll tell us what we get. So here, let's do that, 50. We get super close to 3. That is definitely good enough to guess what the limit's going to be. I'm going to say limit's definitely 3. So what I'm going to do is go back, and how am I going to write this? So, I mean, usually I just like kind of gloss over it on the board, and I'm like, yeah, so there, it's obviously. All right, so let's do some writing. Let's say that the sum from n equals 0 to k of 2/3 to the k, nope, to the n, this is too many letters, man, is equal to 3 minus, I'm just gonna cheat and look back at the calculator. It was 3 minus 2 times 2/3 to the k. So the calculator did something, right? So then the sum from n, oh my god, to infinity of 2/3 to the n, that was a rough n, should be equal to the limit as k approaches infinity. So does this remind you of improper integrals at all, where like we couldn't do like an upper bound that was infinity on our integrals? I mean, it may not, but it should a little bit. 2/3 to the k is equal to, I mean, so 2/3 is going to go to 0 as k approaches infinity. 2/3 to the k, I should say, is going to go to 0. So this is just going to give us 3 overall. So this is kind of interesting. So what we did was we looked at the sequence of partial sums. So really, I should have, I don't know where to write this, but let me do this. Sequence of partial sums is 3 minus 2 to the 2/3. Nope, 2 times 2/3 to the k. Ooh. Okay, so I think that's good. And what we wanted to do is just find the limit of that, right? What's the limit of the sequence of partial sums? The calculator did us a big favor when I accidentally hit enter, and it just gave us a formula for the partial sum. So like if I want, when k is equal to 35, I just plug into this formula and it gives me the partial sum. It somehow adds up from 0 to 35, the results that you get, which is awesome. And we want to talk about how you do that, but we're going to talk about that later. I think in the next set of notes, not this set of notes. But anyway, that's a really good start to sequences. So sequences, we're really, really concerned with series, to be honest. But to investigate series, what we do is we make our sequence of partial sums. And then we take a look at the limit of the sequence of partial sums. Like, what is that approaching? If that is approaching something, then we say that the series itself is going to converge to that value. So I'll be back in the next video. We'll do some more, and I will see you there.